Now let's talk about the section 5. The inverse trigonometric functions. So, by now, we have been doing such things. We know the angle, and then we find the trigonometric function values, right? For example, if we know the angle pi over 6, then we know the sine of the pi over 6 is equal to half pi, right? So now, if we know one angle theta for which the sine theta is equal to 1/2, then what is the theta? So we need to find the angle for which the sine is equal to 1/2. So definitely one answer is the pi over 6, right? Now, this just is the question of the inverse function. And let's go to the graph of the sine function. We know the sine function is like this, right? This graph is like this. And we can draw the horizontal line like this. And this horizontal line just crosses this graph at more than one place. So that means overall, this sine function y equal to sine x is not a 1-to-1 function, right? It's not a 1-to-1, so not a 1-to-1, so it's not invertible. That means you cannot find the inverse function for this sine function on the whole domain, the set of all real numbers. Now, if we restrict this sine to the interval from the negative half pi to half pi, then we get a graph like this. Now this time you can see this graph passes the horizontal line test. Any horizontal line crosses this graph at most one place. So that means the sine function restricted to this negative half pi to half pi is a 1-to-1 function. And in this case, is invertible, then we can define its inverse function. Okay? So when we restrict y equal to sine of x to negative half pi to half pi, then this function, okay, this y equal to the sine of x restricted to this closed interval is 1-to-1 function. Then it's invertible. Then we can define its inverse function. We denote this inverse function as the f inverse of x equal to inverse sine of x. Okay? So now we can get the domain and the range of this inverse function. We know that domain of the inverse function is equal to the range of the original function. So let's go back to this graph. The range of this original function is from the -1 to +1, right? So then the domain of the inverse function is just equal to the range of this arranged function. So therefore, the domain D of this inverse sine is equal to -1 to 1. And what is the range of this inverse function? The range R of this inverse function, which is equal to the domain of the arranged function. So that is the -12π to 12π, right? So the range of the inverse function is equal to the domain of this arranged function, close interval, from -12π to 12π. And we know the graph of the inverse function is the reflection of the graph of the arranged function about the line y equal to x. Let's look at the graphs of the arranged function, original sine function, and the inverse sine function. This green one, like this guy, is the graph of the original restricted sine function. And this red one, which is the reflection of this green one about this y equal to x. Okay, that is the graph of the inverse sine function. And from this graph, you can also see the domain is from the -1 to +1. The range is from the -12π to 12π, right? And sometimes we also call this inverse sine as the arc sine, like this. So we may use the another notation is the arc sine of x. This is same as the inverse sine of x. Why? Because the y equal to this arc sine is the angle whose sine is equal to x, right? And this angle is also the arc length, okay, for which the sine is equal to the x. You look at this graph. So this angle is measured by the arc length of this intercept arc, right, in this unit circle. So now we know the sine value x. Then we need to find the angle whose sine is equal to x. So that is just find this arc length. So this is why we call the inverse sine function as the arc sine function. And you need to note the difference between the inverse sine and the reciprocal of sine. You know, here this is the inverse sine. The reciprocal y over the sine of x. This is written as the sine of x raised to -1. This is totally different from the inverse sine of x. Okay, so you need to notice this difference.